There we go. We'll do it that way. How's that look? Okay. AI deployment challenges. Boy, I could have picked a lot of topics for this one. One of the things I find that's interesting is that if we say infra, people tend to think about the actual training process. So we don't really, I don't even know what people are going to come to when we call, what is it AI ops? Is it knowledge ops? I don't know what we're going to call it. So I'm just calling it AI deployment challenges right now. And I decided to pick just 3 challenges that we've kind of run into while building TrustGraph. Oh yes, by the way, I don't know why am I shilling my podcast, Our Agentic Future, which I am the co-founder of TrustGraph, so I should probably mention that too. So which 3 challenges did I pick? Dependencies. Boy, nobody ever talks about that one. They can be really, really big. APIs, that's a fun one. And then, what happens when you try to design a system where your latencies can be 2 or 200 seconds? But first of all, the sad tale of my melting laptop. Yeah, that's actually my CPU temperature when I try to run anything than that particular embeddings model. Why? Because what happens when you import transformers? Well, it's easy, but what actually happens? Because if you look at transformers, it's a small package. I think I checked today, it's like 10 meg. That's not that big. But what actually happens when you import transformer? What else does it bring? Anybody? What else comes with it? CUDA, yeah, that's the biggest one.
Parallel.
Well, you're also going to get probably either Torch or TensorFlow. So when you talk about Torch and CUDA together, you could be looking at 3 gig. Now, it doesn't look that big because the transformers package isn't that big. So you're getting a lot of stuff coming onto your machine, and it can really eat up a lot of compute and a lot of resources. Ollama, what happens when you try to do this with Ollama? It's a little bit better. They've done a really good job of making Ollama a little bit more efficient. But I kind of get the same problem. A lot of people, some of our users have asked us about nomic embed text. I guess that's a pretty popular model these days. Still, I almost had to get the fire extinguisher for my poor laptop. And it's only 274 meg too, so it's not a huge model, which is interesting. I specifically called out these embeddings models because if I pulled an LLM that size, it would probably run okay on my laptop. But these, like an embeddings model, when you're churning out a lot of embeddings, it can really, really, really drive up the compute. What are some other things that are really, really bloated? Oh, so what if you're designing a system that not only needs Hugging Face models and needs Ollama, but you also have users that want to use Vertex AI on Google Cloud, or they want to use AWS Bedrock. Well, as of right now, best we know, when you actually want to call Vertex AI, you got to import gcloud, the whole SDK, the whole thing, which is like, everything you could possibly ever want to use on Google Cloud when all you're trying to do is call one function. You're using one function to invoke an LLM. AWS Bedrock, a little bit of the same way. To use it, Boto 3. Also a huge bloated package, which, you kind of wish, why did they do it this way? Can't we just use a RESTful API? Interestingly, Azure did that. So if you've used Azure AI Studio, they give you an endpoint, they give you a bearer token, and you go crazy with it. So we've all been there building demos, and we want to do things fast, and we want to make notebooks so that we can share, and import transformers, import Ollama, import these SDKs are great. But what happens when you're actually trying to deploy infrastructure? Like we were talking about earlier, IAC, you're actually deploying infrastructure into AWS or Google Cloud. All of a sudden deploying 3 gig of unnecessary dependencies, it costs money. And there's a lot of frameworks out there that are trying to abstract all of this. So what about them? Well, it kind of depends on how they did it. A lot of people out there, they're trying to be quick. So what did they do? Maybe they imported transformers and they import all these other packages and then just kind of wrote abstractions around of it. The really, really efficient way would be use a REST API approach, which would require a lot of manual coding. And also the thing that it would really require is a lot of reverse engineering. If you've gone through the documentation for a lot of these services, yeah, they document all the Python SDK and maybe Go and maybe a few others. But when you really dive into the REST API, you're kind of on your own. You're going to be doing a lot of reverse engineering. Speaking of reverse engineering, this is ugly. It is ugly. This is actually our, in TrustGraph, this is our Bedrock integration for actually dealing with all the different response bodies that it returns. So how you actually invoke a model in AWS Bedrock is pretty much the same no matter what model you call. But for some reason, I don't know, I don't work for AWS, I can't tell you, the response bodies are all totally different. And if you really look at this code, you're going to go, what? Like it's really, really strangely different in some cases. Like it's you look at this and go like, why would they do it that way? And when you look at their code examples and their notebooks and their documentation, it's not supposed to be like this. But this is the way it is. And at some point, you stop asking why and you just go, I'm glad it works, and you get on with your life. I don't understand why they did this, but if you're trying to design a system for somebody and they are an AWS shop and they want to use AWS Bedrock and they want to try out different models, because if you've gone to AWS Bedrock now, they're starting to actually, really integrate a lot of other different kinds of models and use case specific models. They're kind of creating a model marketplace, which I don't think any of us are surprised about. So, if you have enterprise clients, they're probably going to be interested in like, hey, I want to be able to use all of these. Well, guess what? There's no uniformity in Bloated 3. The latency problem. If we look at Gemini, that's kind of the fastest model out there right now. It responds really fast. You can 2 seconds, 15 seconds, 20 seconds might be the max, but most other models out there, you can still get some really long response times. If you give it really long context, you could easily be over a minute, even 2 minutes. I remember there were some times where, you really, hey, is this million token context window actually going to work? And 5 minutes later, it's still going. So it can be quite long. So how do you actually know what's going on with your system? Well, you need an observability and telemetry stack. This is actually some screenshots of our integration in TrustGraph using Prometheus for getting the telemetry out and actually displaying it in Grafana. And while most of this is pretty standard stuff, we have error detection, we can see what's going on in our backlog. The one that ends up being really, really useful is this one at the bottom, in the middle, the token throughput. So what we're actually doing is we're measuring in real time, the token throughput in the system, whether this is, the input or the response. And it's really useful because you see stuff like this. This is actually a screenshot from me using Claude 3.5 Haiku in AWS Bedrock. And you're looking at here like, what happened? Well, that's actually what I was thinking at first, like, what happened? So what happened was we got a bunch of rate limit errors that turned into actual throttling exceptions. And you're probably thinking, how many requests were you hitting it with? Not that many. One of the things that we've seen is that most of these services, they have an RPM limit, they have a token per minute limit, and we don't really, in theory, shouldn't be that close to it, yet we hit these rate limiting errors. So, what do? When you're designing a system, now you're worried about, what is a timeout when you're talking about 2 seconds versus 60 seconds, 200 seconds? How do you set that limit? And then most people say, well, we get an error, we'll just retry. Well, what happens if you're getting rate limit errors and you just start hitting with retries? You're going to get a lot more rate limit errors. And those rate limit errors are going to turn into them just shutting off the tap for some amount of time. And if you're only using one user, these aren't those big problems. But you have lots of users that aren't communicating with each other, it's much more difficult to design a system with that. Speaking of systems that are designed with all that in it, TrustGraph is open source. Agentic orchestration platform, sure, that's what I'm calling it at the moment. If you have a better idea, let me know. You can come out, try it yourself and tell me. We also, like our previous speaker, are hosting a workshop next week at the AWS Lofts. Apparently it's the fashionable thing to do these days. It is an agentic graph RAG workshop with our partners from Europe, MemGraph. Dominic, the CEO and founder, and their CTO, Marco, will be here, great guys. And we're going to be getting hands-on with agentic systems, agentic graph RAG, and even I've offered, I didn't put the QR code up there, but we're making cognitive cores for anybody that is, for any knowledge base that they can try out at the workshop. Just let me know and we'll build it for you.